Okay, first one, probability of rolling a 3 on a die. We know that there is 1 3 out of 6 sides. So that what would the probability be? What letter did you pick?
B.
You picked B? Anybody else pick B?
I pick B.
Very good. All right, so I'm going to put B. I'm also going to put 1 6, just so like I see the number there and I don't have to go back and wonder what it was. Okay, the probability of flipping a coin and it's landing on heads. Who has that one? Nadine, what you got? You got E 1/2. Anybody else get 1/2?
B.
Good. There is one head out of 2 sides, so it is E, which is 1/2. All right. Last time I did such a bad job drawing those bags of marbles that I didn't even try this time. It says the chance of selecting a red marble from a bag that has 6 red and 4 green marbles. I'm wondering if anybody thinks they have that one. Kelly, did you get that one? Yeah, number 3. Did anybody else get 3/5 for that? Yeah? So it was D, right? It started with 6 out of 10 because it was 6 red out of 10 marbles altogether. And then you can simplify that fraction to 3/5. And if you were not here last class, you didn't see how we could use Desmos. Some people are quite good with fractions, and some people want to learn about fractions. And some people would just rather let Desmos do all the work. And I'm fine with whatever goal you have with fractions there. But I will show you real quick, just in case you want to use Desmos, how it works. So when you're in Desmos, if you have the fraction 6/10 and you want to simplify it, when you put it in there, it gives you a decimal, but if you click on this little fraction over here, it will give you the simplified fraction of 3/5, okay? Where does that want to go? I guess it wants to go right there. Okay. Oh my goodness. My Desmos tab is just going nuts. Oh well. Let's see. So we answered that one and we said it was D, which is 3/5. Okay, the chance of selection of a heart card from a standard deck of cards. That was a tricky one. Does anybody want to explain how they figured that one out? Good morning. Did anybody go directly to the answer, or did somebody have like a first answer before they went to the final answer? Joseph, did you answer that one, the card one? Yeah. What was the first thing that you wrote down? 1/4? So how did you know it was 1/4? Okay. Yeah, so we don't actually know how many cards there are, but there are 4 types of cards, right? Yeah, so the 4 types of cards are diamond, heart, spade, and club. And so yes, it's true that 1 out of 4 are going to be a heart. Did anybody start with a whole deck of 52 cards? That's another way to do it. If you had a deck of 52 cards, 13 of them are hearts. So you could have started with 13 out of 52 and then gotten to 1/4. But I think Joseph's method is pretty direct. So there's 1 heart out of 4 different shapes altogether. All right, the probability of rolling 2 3s in a row on a die. So this is the kind of problem where we had to multiply. Did anybody multiply to find their answer on this one? Dion, did you multiply in problem 5?
On the bottom?
No, actually up here. The probability of rolling 2 3s in a row on a die. Did you multiply 2 numbers to get that? What did you multiply? All right, so there's 6 sides, right? So the first probability was 1/6. And then the second probability is 1/6. So when you have to find the probability of two things happening, you multiply them together. And Dion, which answer did that give you?
136.
Yeah. So that's how we get this answer here. So when you have to roll two dice, you multiply their probabilities, and then 1 times 1 is 1, 6 times 6 is 36, which is answer C. All right, the last question says, if you could win a prize in one of these games, which game would you choose and why? So I'm going to ask you, actually, yeah, I'll take your answer in just a second, Shelby. I'm going to ask everybody to vote too. But let's hear Shelby's reasoning. What were you thinking?
I picked number 3 because there's more than a 50% chance winning.
All right, so that was some solid reasoning. She picked number 3 because there's more than a 50% chance of winning. So that means winning is likely. Anybody have want to also pick number 3 or give a different choice? You pick number 3? Yeah, Lonnie picks number 3. Okay, so 3 was D. So if you want to pick the dice game, which is the first one, raise your hand. If that's the one you would pick to play. If you would pick flipping a coin and landing on heads, raise your hand. 1 person, 2 people, 3 people, okay? If you would pick the marble one like Shelby, raise your hand. 1, 2, 3, 4. If you would pick the card game, raise your hand. Anybody pick that one? And if you would pick rolling 2 dice, raise your hand. All right, that is definitely the hardest game to win. You only have a 1 in 36 chance of winning, right? So if you played that game 36 times, you would only win it once on average. All right, so that one was a tough one to win. I do think that the one that most of you picked, the flipping a coin and the marble, would be the best ones because they would give you the highest odds. This one's 50% and this one's 60%. So you should have answered number 6. I'm reminding you to write an answer. Do not write an answer. Write your answer there. All right. I'm giving you a minute for that, and then we're going to start these notes. Okay, so first problem says there are 30 students in the library after school. 11 students had just English homework. These are just English. 4 students had just math homework. 9 students had both English and math homework. And 6 students had neither math nor English homework. All right. So when I say P parentheses M, can anybody raise their hand to explain what does that mean? Like, what is the math there? What am I trying to find? What does the P stand for? What's this whole unit about? Good one. Probability, yes. So the P stands for probability. Probability. And then what does the M stand for in this problem? What kind of homework? Math homework. Good. So the probability a student has math homework. That's what we're trying to find. All right, so we need to find the numbers now. I have 4 students who have just math, and I also have 9 students who have math and English. So altogether, how many students have math homework? I have to add them to the ones that have also English. So how many altogether? 13. You see where he got that? 4 and 9 makes 13 students who have math homework. And that's going to be out of the total students. How many students are there altogether? Shelby says 30. Anybody want to agree with 30? Yeah, there's 2 ways you can find that. You could add up all the numbers, or you could go back to the problem and it tells you 30 students. Okay? So the probability is 13 out of 30. Now you can express your probability as a fraction, as a decimal, as a percent. but the fraction's fine for now. All right. P parentheses M meant probability a student has math homework. What does P parentheses E mean?
English.
What about English? Start with the P.
Probability of student English.
All right, that's good. Probability a student has English homework. Good morning. All right, so we're going to find the probability that a student has English homework. Take a second and see if you can find that. Probability a student has English homework. Okay, number 3, probability a student has English homework. Does anybody want to share an answer for that one? You, Lisa, what you get? How many? No, number 3, sorry. 20 out of 30. Did anybody else get 20 out of 30? Good. All right. So a lot of times people want to focus on just these people over here, but remember you also have to include the people in the middle. 20 out of 30. Did anybody simplify that fraction? 2 out of 3? It is 2 out of 3, yeah. So 20 out of 30 is good, and 2 out of 3 is your simplified answer. All right, we have some symbols coming up, and I want to show you what they mean. So I'm going to make a little key on the board because we're going to keep reusing these symbols. This one means and. Okay, and that means both have to be true. This one means or. And that means one or the other or both. And then that little apostrophe, this little apostrophe here, it means not. Okay? All right, so let's interpret that now. The probability that a student has English, what's that word going to be for the upside down U? Probability a student has English, what's it say?
Homework.
Yes, English homework. But the upside down U is the word and. Okay?
And math.
And math, that's right, thank you. So probability, a student has English and math homework. They have to have both. All right, so look at your Venn diagram. And how many students are both in the math and the English? What does it look like? In the middle here, how many do we have?
9.
Yeah, it's 9. So the probability a student has both math and English homework is 9 out of how many students altogether?
30.
Out of 30, good. All right, on your phone or on your computer or in your brain, I want you to simplify 9 over 30. On your phone, on your computer, or in your brain. All right. All right, so using the key that we put on the board, this is the probability a student has English. What's this word? It's not and this time. What is it?
Or.
It's or, because of the U, okay? English or math or both. So I want you to take a minute and see if you can figure out the probability a student has English or math or both homework. While I write those words, I want you guys thinking about the number. students who have English or math or both? Some people are thinking, no, they don't agree. So let's look at it. All right, English or math or both. It could be any of those. So if we add them up, does that give us 24 students? It does. Out of how many students altogether?
30.
Still 30. That hasn't changed. Next class, we're going to have some where your denominator starts changing, but this time it did not. So we had 24 over 30, which simplifies to what? 4/5. Good. All right, these are tricky ones. The probability, remember I said that that little apostrophe means not? The probability a student does not have math homework. Does not have math homework. Okay, so I already know that 13 students do have math homework, right? How many students do not have math homework? 11 here, and
6.
the 6 that don't have either, okay? So these are the students who don't have math. They're outside of the math bubble. So how many is that?
17.
Is he right?
Yeah.
It's good to agree with yourself. Yes. There are 17 students outside of the math bubble out of 30. Does this one simplify?
No.
It doesn't. You know why? It's because 17 is prime. 17 doesn't have any factors. The probability a student does not have math homework, we did. This is the probability a student does not have English homework. All right, Shelby's on it. We'll see if you agree. Okay. Shelby gave us two answers. She gave us 10 out of 30 and 1/3. What do you think? Does anybody get the same answers? Kelly does. Kenny does. And Wendy does. All right, let's take a look and see if it makes sense. Not English. So not English means not these two, but these. And that does make 10 out of 30. And I do agree that that simplifies to 1/3. All right. So I think our next problem is going to be oh, it's not a problem about you guys. The problem about you guys is coming up at the end, but we need to collect the data for that. So we're going to take a short break, but during that break, I'm going to ask you to do something. I'm going to send you guys one at a time to list what kinds of social media you use. There's only 3 choices. I know some of you use some that are not listed there. We're just talking about Snapchat, Twitter, and Instagram. All right, so let's finish up our break and put our phones down. Show me that you're ready. Thank you. Okay, so restaurants often have a special of the day. If they have their regular menu, and then they have a special of the day. And often they're going to have an appetizer special, an entree special, and a dessert special. And those are things that they made maybe just enough of for today, or maybe like it's a special for the whole week, but it's a special, okay? So this restaurant had 100 customers yesterday, and of those customers, 20 had all 3 specials. 10 had just the appetizer and entree special. 12 had just the entree and dessert special. 15 had just the appetizer and dessert special. 5 had only the appetizer special. 4 had only the entree special. And 5 had only the dessert special. And 29 had none of the specials. I'm going to help you put in 2 of these numbers. And then I'm going to give you some time to see if you can figure out where the other numbers go. All right, so let's look at, I'm going to leave you guys the first one about all 3 specials. And I'm going to put in, that's funny that I misspelled appetizer. I wrote appetizer. I'm going to put in this one here. 10 had the appetizer and entree special. All right, so I'm looking for the place that's in appetizer and entree, but not in dessert. Do you see it? Appetizer and entree, but not dessert. That's up here. So that's where I'm going to put these 10. All right, and then I'm going to also put in these 5 right here. So it says 5 had only the dessert special. So those 5 are down here in dessert and not in any of these others. So that would be down here. Okay, so I put in those 2 numbers. I want you to go back now and put in all of the numbers. Give it a try. Talk to a friend. Ask questions. All right, so we said 10 had just the appetizer and entree, so that's here. 12 had just the entree and dessert. So entree and dessert should go here. So 12 had the entree and dessert. 15 had the appetizer and dessert. So 15 is here. Oh, I did skip over that number in the middle. What number should go in the middle?
20.
20, yeah. It's at the beginning. It says 20 had all 3 specials. Okay, so let me continue on. 5 had only the appetizer, so that's only appetizer out here. 4 had only the entree. We did this one already. 5 had the dessert. And 29 had none of the specials. Where do I put the 29? In the corner, yeah. So you want to put it outside the circles, but inside the rectangle. So you could put it here, or here, or here, or here. I don't know why traditionally I always put it right here in the bottom right corner. But actually any of those corners is fine. All right, any questions on how you make the Venn diagram? Okay. P, probability that the customer got the appetizer special. So I'm going to write that. Probability of appetizer special. Now notice it doesn't say just appetizer, so I need to include all of the numbers that are in the appetizer special. I kind of want to write, but then I want to be able to erase it. Let me see if I have a pencil here. Okay. So when I'm talking about the appetizer special, I'm talking about everything inside of A. You see that? Eamon, what numbers are inside the appetizer special circle? I'm talking about this whole circle here. What numbers do you see? 5. Good. What else?
15.
5, 15. 2 more.
20 and 10.
20 and 10. Good. So we're going to add up all those numbers. 30, 40, 50. Anybody else getting 50?
Yeah, 50.
Yeah. And it's 50 out of 100 customers. Good.
Yeah.
Okay, so Dion says that's 1/2. Is that right?
Yeah.
It is. Good. Okay. So now we're going to use that same strategy to do probability of the entree special. So this time we're just looking at the E circle. There are 4 numbers in it. We have to add them up. So go ahead and do that. And then compare with your neighbor and see if they get the same as you. Okay. How many people got the entree special when we add up all of these people?
46.
All right. Anybody else get 46? Holly got it. Eamon got it. Wendy got it. And Brian got it. Good. Amro, you also got it. Good. All right. Yes, I also get 46 when I add these up. So I've got 46 out of 100. Oops. I think that's just 23 out of 50. I think I can just half those. Okay. All right, one more. Probability of the dessert special. Does anybody in here take the culinary class?
No.
Culinary, yeah.
That's a good question.
You did? Because they make these meals that they sell to the teachers, and they are so good. I'm so excited. All right. So probability of the dessert special, that's in here. So this gives me 20, 40. I'm getting 52. Can you guys confirm 52? Okay. So probability of dessert special. And that is 52 out of 100. Let's see, 26 out of 50, 13 out of 25. Yeah? Okay. All right, so here's the tricky ones. Make sure you're caught up so that you can do these tricky ones, and then I'm going to give you guys time to work on this practice here. Okay. The probability that a customer gets the appetizer, what's the upside down U mean? Look on the board, the whiteboard. Upside down U means what word?
And
It means and. Good. Probability they got both the appetizer and the entree special. These are these people here in the middle. See that? Not the very middle, but these here. They're in both the A circle and they're in the E circle. How many are there? 30. Okay, see what we're talking about? We're talking about these. They're in the appetizer and the entree. So that was 30 out of 100. Oh, and that simplifies, right? Anybody have it? Kelly, what'd you get? 3/10, good. I'm going to give you a minute for the next one because this is going to take a bit of work. Probability that they got the appetizer or the entree or the dessert or any combination. This time I'm talking about anybody who is in any circle. Okay? Now I think that some of you guys might be able to think of a quicker way, but one way to do this is to add up all the numbers in all the circles. If you know a quicker way, you can do that too. All right, so probability of appetizer or entree or dessert or any combination of those things. So I'm going to give you a minute to think about that. Add up some numbers.
where we add up everything in every circle.
That's right. Did anybody do it yet? Add them all up?
Yes, everyone.
Did anybody else get 71? You got that? You got that? Okay, good. Did anybody think of a different way to do it?
100 minus 29.
That's right. There's 100 people, and we know 29 are out here, right? So you could have subtracted also. But either method works, and so we got 71 out of 100. And that was the probability that you got any of the specials. A or E or D or any combination. All right, and the last one has that little apostrophe. What does the apostrophe mean? It's on the board. Amro's on this board right here, on the left.
How many did it?
Right. So it literally means the word not, but Dion interpreted it correctly. So how many probability that a customer did not have the dessert special?
Um, 19. Plus 29.
Let's see.
49.
All right. I like where you're going with that. I'm just trying to catch up. So Dion's looking at all of the numbers outside of the dessert special. Okay, so here's our dessert special here. So he said these numbers make 19. And then that's 29. And he added those up to get how much? I think he said 48. Is that right?
I think, no, I don't think it's right. I'll just forget.
Brian thinks it's right. What do you think, Kenny? Did you get 48? Yeah. So 48 people did not have the dessert special out of 100. Let's see, 24 out of 50. 12 out of how many? 12 out of 25. Well done. Okay. So here's what we're going to do. Those of you who did not finish your project, you may work on the project first, and you can work on this one later, on the bottom, okay? Those of you who did finish your project, then work on this practice here, and then you're gonna have free time if you finished your project. In your free time, you might choose to help a neighbor. That would be a nice thing to do.